implementing CNN for image classification with a PyTorch using EuroSAT dataset. In this tutorial, we will build a convolutional neural network to classify images from the EuroSAT dataset using PyTorch. EuroSAT is a dataset from Sentinel to satellite images with a 10 class for different land use types. Each class contains between 2,000 to 3,000 images. First, let's import the necessary libraries, such as importing standard libraries, import OS, random, TQDM, and import libraries for data manipulation and visualization, such as Matplotlib, PIL, Seaborn, Pandas, and NumPy. Then importing deep learning libraries such as Torch, Torch Vision, Torch Summary, and so on. Because the size of dataset is large, we recommend to use GPU. Then setting up the environment. We will set a set for reproductory. Set is equal 42. Then check if the GPU is available, and then set the device accordingly. Now loading the EuroSAT dataset, we download and unzip the EuroSAT dataset. Creating a custom dataset classes. You will create a custom EuroSAT dataset classes to handle the images and their corresponding labels. Now data transformations. We define transformations for training and testing. Input size equal 224. ImageNet mean 0.48, 0.45, and 0.406. ImageNet standard deviation 0.229, 0.224, and 0.225. Then preparing the data. We will load the data and divide it into training and testing sets. Train size equal 0.8. It means 80% of the images for training and 20% for testing. And create data loaders for different data handling. Visualizing sample images. You will visualize some sample images from training set to get an idea about our images. We define show sample images. Data loader, class names, and number equal 3. Figure size equal 8 by 8. Then iterate over each subplot position in the grid. These are examples of our dataset. Residential, pasture, sea lake, forest, permanent crop, and so on. Now let's building the model. We will use a pre-trained NestNet 50 model and modify it the final fully connected layer to match the number of classes in our dataset. Now let's define loss function and optimizer. We will use cross entropy loss as our loss function and SGD as our optimizer. Now let's train our model. We'll define the training loop. To evaluate in the model, we will define the evaluation loop to test the model on the validation set. So we define evaluate, initialize variables to track losses, correct predictions, and store all predictions and levels. Then disable gradient computations for evaluation. Calculate average loss and accuracy over the entire dataset. Then return the computed metrics. For training and validation loop, you will train the model and validate it after each epoch, saving the best model based on the validation loss. We set number of epochs to 30. Because the dataset includes huge images, it takes a bit long time. We also define the file path for saving the best model weights and save the best model weights to the file. Then print the message indicating that the model has been saved. The result of epoch 1 is the train loss 0. Close to 99 and accuracy 0.71 and validation loss 0.33 and accuracy 0.91. Because my runtime may last up to just 50 minutes, to make this tutorial simple, we changed the number of epochs from 30 to just 5. Now we pause the video till all epochs finished. Now running the epochs finished and it's saved. Now let's loading the best model for evaluation. Deploy the best model saved during training and use it for our evaluation. Now let's plot in the confusion matrix. We will calculate and plot the confusion matrix to visualize the performance of our model. Overall accuracy is 0.977, so it may be increased by using more than just 5 epochs. That's how confusion matrix looks like. Most of the annual crops classified correctly, 573. Just 8 images mistakenly went to the permanent crop. And for the forest, most of the images correctly classified. 3 images classified as pasture. Now let's making predictions on the sample images. We use our trained model to make predictions on some sample images from the dataset. That's the result. It's predicted as forest, and so forest, and this one classified as industrial, and it's correctly classified. Highway, this image classified as a residential area, and it's correct. And finally, this one classified as river, and it's correct. In conclusion, in our tutorial, we successfully implemented a convolutional neural network for image classification using the EuroSAT dataset and PyTorch. We covered the following steps. Loading the dataset, we downloaded and unzipped the EuroSAT dataset and prepared it for training and testing. Then, pre-processing, we applied necessary transformations to images to make them suitable for the model. Then, building the model, we used the pre-trained ResNet 50 model, adapted it for our classification task, and examined its architecture. Then, training and evaluation. We trained the model, evaluated its performance using accuracy and confusion metrics, and visualized the results. Finally, making predictions, we used the trained model to classify sample images and visualize the predictions. To increase the performance of the model and accuracy, you can adjust parameters like learning rate, batch size, and number of epochs based on your specific needs. And this workflow can be adapted to other image classification tasks with different datasets by modifying the dataset path, class names, and models. References used for preparing this tutorial: Helba et al. EuroSAT, a novel dataset and deep learning benchmark for land use land cover classification. Reid Falcona, land use land cover classification, beating the benchmark, available on GitHub. And Ankur Mahesh and Isabel Tingzon, land use land cover classification using PyTorch, available at this link.